force velocity curve. And the thought used to be, and conventional wisdom kind of was, you need to do a little bit of everything. You need to hit all points on the curve. You need to do some stuff at max velocity. You need some stuff kind of in the middle, some stuff super slow, generate a lot of force, etc. The thought about power production has changed. I will let you take it from here as someone who has looked deeply into this. I'm excited to hear how, one, what research piqued your interest in why you thought that was like a tipping point to change, and two, how it has really changed your programming.
Well, I think there's a couple of things. So it's not necessarily that we don't use the middle of the curve. We just don't use the middle of the curve for adaptations, right? So when we're actually trying to create adaptations, we've got to be on one end or the other. So, it's hard to illustrate this if you're listening on a podcast driving on the highway right now, but imagine that force velocity curve. On the left of the curve is force. On the x-axis is your velocity, and then you have that slope that goes from top to bottom, right? And then the other line there is power, right? So there's no power in the beginning, and then you have what looks like that Yerkes-Dodson curve, that upside down U, where power peaks right in the middle of that.
It's a parabola, isn't it?
Yes, it's a parabola.
I just wanted to say parabola.
It is a parabola, yes.
Yes.
So at the top of that parabola is the peak power, and then it starts to come down as well, right? And then on the left end of that slope is maximum force. So if you want to maximize force, this is where you're going to do things like overcoming ISOs, which I've been playing a lot with, right? Do things like heavy-ass deadlift, heavy-ass squat, bench, right? And then on the very top end side of that, the velocity, right? That's your med ball throws, plyos, assisted plyos, things like that. In the middle is where kind of like your Olympic lifts live, and some of your other like ballistic strength, speed strength type of stuff live, right? Where you're trying to maximize power. So research has shown lately that like when you're trying to create adaptations in the muscles don't necessarily respond to maximum power. They respond to either end. They respond to maximum force or maximum velocity, right? And this kind of goes back to the stuff that we test. So when we test an athlete for non-counter movement versus counter movement power production, we're looking at what's happening in that stretch shortening cycle. We're looking at if they're a strength-based athlete, if they're a velocity-based athlete, right? So if there is not a huge gap in that non-counter movement to counter movement power implement, then we know we're going to be on that velocity side. We're going to do a lot of plyometrics. We're going to do some assisted plyometrics, med ball throws, things like that. Whereas if there's a huge gap, then we're going to be on that strength side. And it makes sense. So now there's research out there to support that where, hey, like it's good to work on the power to work powerful lifts, but the true adaptation is happening at this end of the curve and that end of the curve and not in the middle.
So to kind of summarize, make sure I understand what you're saying here. You either want to be able to like have the more capability to like lift heavier, right? Like you want your 1RM, your 5RM, like that super high strength end to grow and program around that. That will help increase ability. Or you want it on the complete other end where you're like 100-yard sprint or 100-meter sprints.
Yeah,
right?
let me.
And if you raise one of those ends, your ability to produce power across the entire curve will increase.
Correct. So let's put it this way, right? Let's do this where we say let's just use squats for example, since everybody can understand squats. Right.
For some reason, as you said that, in my head was your like multiple voices Instagram.
It is. It is.
Let's talk about squats.
That actually is going on right now. So let's talk about squats. So a powerful squat, right? Let's say a powerful squat or power squat. Let's say we're trying to do like 225 pounds and trying to move that as fast as you can. We've got a Tendo unit on it. It's measuring bar speed, and we're going to get some sort of velocity-based measurement on this, right? So for us to increase that power output at 225, we're not training at 225. For us to actually increase that power output, which is our maximum output, we have to be either so far below that or so far above it that we're almost in a different phase or a different type of exercise, right? So again, that's why I like the overcoming ISOs at different angles, right? So that's when I would put myself underneath like the safety arms and try to push up against it where it's not going to move. And I'm holding those contractions for 2 seconds, 3 seconds at the most, maybe, for a set of like 3 to 4. And then you have your assisted plyometrics, right? Your assisted plyometrics where it's an overspeed and you're jumping as high as you can with the assistance of a band or a TRX catapulting action with your arms, right? So for me to implement the change that I want, which is to get more powerful at 225 and move that bar as fast as I can, I shouldn't be training at 225. I should be training at a weight that I really can't move that fast, and I should be training at no weight where I'm moving faster than I can even on my own. That's how I implement that change.
So in a way, it sounds like we're actually just manipulating the formula for force, right? Force equals mass times acceleration.
Yeah.
Mass, the heavy stuff, acceleration, moving. And like you need to be able to either increase your ability to move mass or increase your ability to accelerate. Right. And if you just kind of live in the middle where you're not pushing either end, you're just kind of maintaining what you have. So like this makes sense on that level. And then you get down to the programming of how to best do it, which I like on the strength side too, of like overcoming ISOs and things like that, because that guarantees force production at a maximal level while also, by the way, maintaining safety versus like, let me see how heavy I can go on a 1RM.
Right.
One thing that I did think was interesting, and this I think is a little bit of a side shoot of this conversation too. I saw a really great post the other day from Lee Boyce, who's a trainer out of Toronto, or as they call it in Toronto. And
I thought you were going to say the 6.
No, I'm not Drake. Anyway, the point is, Lee talked about like, hey, if you have a 500-pound squat, which obviously is very heavy, but let's say you are one of these supreme athletes who has a 500-pound squat. But this is true at a 300-pound squat, whatever, 225, 185, whatever your max is. Are you better off trying to go for 505 or 510 and like progressive overload?
Right.
Or are you better off trying to get 500 for 2 if you were really truly stuck at 500 for 1? And he's like, I think it's way more impressive, and you're obviously being able to generate more force if you do 500 for 2 versus 505 for 1. Yes, it's still progressive overload, but like your capacity to move more weight actually is going to increase more by trying to work towards 500 for 2.
Right.
And I thought that was interesting and kind of plays into that of like when we think about how to maximize the strength side of it, especially, I think that's something we need to consider because we so often push for like such a marginal improvement, a very small percentage movement, especially as the weight goes higher and higher. A 5-pound increase becomes significantly less in terms of percentage that you're actually growing versus if you were to double the number of reps from 1 to 2, you are always going at 200%.
Right. True. And I would take that even further, right? So Lee Boyce has some great stuff. If you don't know who Lee Boyce is, go find him, read his stuff. The other person how I would tell you to or encourage you to follow and read his stuff is Matt Rhea. And Matt has said, look, like the more that he's in it, and Matt has been in Indiana, he was at Alabama, he's done all kinds of great stuff. The more that he's in it, the more he realizes that maximum strength isn't the quality that we're really looking for. The quality that we're really looking for, the quality that we're really training for is maximum power. How much power can we produce and how instantly can we produce it, right? So if maximum power is the goal, again, you take a look at a 500-pound squat, is your goal to reach 505? Is your goal to reach 500 for 2? I would say for me and our athletes, it's neither of those. For me, it's always going to be velocity based. So if I know that I can produce if I know I can lift 500 pounds in a squat, all right, how many watts does that equate to, right? When we're measuring the bar speed, and if that equates to 4,000 watts, can I now produce that 4,000 watts at 400 pounds instead, or can I do it at 300 pounds instead? And if I am dropping off, how far am I dropping off, right? And this is where elite athletes really live, because elite athletes, for them to maximize their power, they don't need as much of a stimulus. Whereas novice athletes or beginner athletes, they need more load to be able to produce more power. Whereas expert athletes, elite athletes, don't need as much of that resistance, and they can still produce a lot of power. They can maximize their power without having to go so high in their load. And that's really, if you're training athletes, that's really what we're looking for.
As was said in a very early episode of this podcast, one of the tenets of this podcast when it comes to performance training, there are no bars on the field.
There are no bars on the field.
And so at the end of the day, like, that's the goal. I remember, early in my career, and we were talking about like Kaiser squats and stuff, and like you were kind of teaching me how to use all that equipment, and you're like, this is the goal. The goal is not to go from a 200-pound Kaiser squat to a 250-pound Kaiser squat. And if you're lucky enough to have Kaiser equipment, like, this is, and you're training for power, like, this is how you use it. Like, you do not try to go for a 250-pound Kaiser squat when you were doing 200. You try to generate more power at 200 or 150 or whatever it is that your weight is. And I think that gets back to, like, how do you actually do that? Well, what you do is you maybe do a 500-pound ISO that you can't actually move on the Kaiser squat and do those max efforts. And then can you drop it down or actually get out of the Kaiser squat machine and do assisted jumps and that same movement pattern, generating even more velocity. And again, that's truly like the velocity. At that point, we're not talking about the force because you have the band that is assisting you with the force you were naturally generated to move you faster than you could by yourself. And you are training both your muscles and your brain to allow you to go that fast and to generate that velocity. You put it back together at, let's say, 200 pounds on that Kaiser squat. Now you've generated more force or more mass, the ability to move more mass, and the acceleration piece generate more force, and up goes your wattage.
That's right.